Okay, now let's do a few sums on diffraction. Now remember in diffraction pattern we had single slit. We had a single slit and the width of the slit was taken as A. And when we take the screen at a distance D, then if it spreads over a certain angle, it is the central region. From central region, this distance is the point, this is the point where the first minima occurs. So the point where first minima occurs, there the central bright band ends. Okay, central bright band end कर रहा है कहाँ? When the first minima occurs, right? So we have done this as what? This distance as कौन तो बोले थे? एक कोई बोली? कौन तो बोले थे distance का? नहीं वो तो ये सम के लिए इन जनरल हम लोग क्या निकाले हैं ये लैम्डा कैपिटल डी बाई ये लैम्डा कैपिटल डी बाई ए है दिस इज द हाफ ऑफ द सेंट्रल ब्राइट बैंड सो द होल सेंट्रल ब्राइट बैंड इज दिस होल लेंथ इज 2 lambda d by a. Now in this question number 34, they are saying given that a screen is placed 2 meters away from a narrow slit. So this is a narrow slit. This screen is placed 2 meters away. So D, capital D is how much? 2 meters. They are saying find the slit width. They have asked you to find out A. If the first minima lies 5 millimeter on either side of the central maxima, means this is the central maxima position. Okay, this point is the central maxima position, and the first minima which is present, it is 5 millimeter away from the central maxima on either side. So this is 5 millimeter. This is also 5 millimeter. Now they are asking to find out the value of A. So see, this distance is already known to us, lambda d by A. Now if you don't remember this distance and you remember the formula for central bright band, which is 2 lambda d by A, then you can also use that formula and write is equal to 5 into 2 millimeter. 5 millimeter into 2. Why? Because it is 5 millimeter on one side only. So the other side will be also 5 millimeter. So you write central bright width of central bright band is equal to 5 millimeter into 2, that is 10 millimeter. So therefore we can write 2 lambda d by A is equal to how much? 10 millimeter. And if you are writing the half only, that is lambda d by A, take it as 5 millimeter. If you are writing lambda d by A, take it as 5 millimeter. अनुराग जब समझा रहे हैं तब इधर उधर मत करो, सब पढ़ देंगे हम जाके. अब वेवलेंथ कितना दिया हुआ है यहाँ पर सब में?
5 into 10 to the power minus 10 minus 7.
कैपिटल डी दिया हुआ है 2 मीटर. ए का वैल्यू निकालना है और ये 10 मिलीमीटर है ना, इसलिए 10 into 10 to the power -3 करना पड़ेगा. ठीक है, मीटर में कन्वर्ट करने के लिए. इससे सॉल्व करके यू नीड टू फाइंड आउट द वैल्यू ऑफ ए. कितना आया?
2 10 to the power minus
2 into 10 to the power -3 मिलीमीटर. नहीं, -4 मिलीमीटर आना चाहिए. -4 मीटर आना चाहिए. तभी 0.2 मिलीमीटर आएगा आंसर. 2 into 10 to the power -4 आना चाहिए. Is that clear? So most of the sums are based on central bright band. Question number 35. It says that monochromatic light passes through a slit of whose width is 0.05 millimeter. At what angle will there be a third minimum? Now remember, for secondary minima takes place at sin theta n is equal to n lambda by a. So they are asking you to find out the third minimum. So third minimum sin theta n will be equal to 3 into lambda by a. Here lambda is given as 400 nanometer. So if we put the values 3 into 400 into 10 to the power minus 9 by a is 0.5 into 10 to the power minus 3. ठीक है? We get a certain value of theta. Now that is so small you can figure out. You can write it nearly equal to what?
Theta.
Theta n. Theta n is nearly equal to this. That is theta n over here. N is 3. Actually, n is 3. So theta 3. So this is the angular width you are getting, and whatever angle you get, that angle will come in radians. Okay. Now, if you want to convert it into degrees, you need to multiply by also pi by 180 by pi. 180 by pi. That will give you the answer in degrees. हाँ बोलो.
थीटा स्मॉल आपका ए का वैल्यू कौन से
नहीं ये दोनों का वैल्यू इवैल्यूएट करके देख रहे हैं ना. वैल्यू जो आ रहा है वो बहुत छोटा आ रहा है, बहुत छोटा एक हाँ इसीलिए. हाँ अगर तुम लोग नहीं भी कर रहे हो ना, अगर तुम थीटा को साइन इनवर्स कर रहे हो और वो डिग्री में करोगे ना, आंसर सेम आएगा. साइन इनवर्स करके अगर तुम डिग्री में आंसर लाओगे ना, तब भी आंसर सेम ही आएगा. ठीक है, तब ये करने का जरूरत नहीं है, डिग्री में डायरेक्टली आंसर आ जाएगा. साइन इनवर्स इज इक्वल साइन इनवर्स ऑफ दैट कर देने से डिग्री में डायरेक्टली आंसर आ जाएगा. समझ में आया ना? और फिर बोला है कि what is the width of the central maxima on a screen located 1 meter away. So now you know width of the central maxima will be formula
लैम्डा कैपिटल डी बाय
width of central maxima is 2 lambda
capital D by
a.
A.
So you know all the values. सिर्फ पहले डालना है 400 into 10 to the power minus 9 ऐसा 9 into d distance between the space is given 1 meter by a is 0.05 into 10 to the power minus 9. That will be the width of the central maximum. Clear? Alright, the rest of them are exactly the same way, same formula is being used at all the places. एक ही फॉर्मूला है, सिर्फ वही फॉर्मूला के बेसिस पे सेंट्रल मैक्सिमा का वैल्यू सिर्फ निकालते जाना है. ठीक है, सो ट्राई द क्वेश्चंस 36 37 38. दे आर वेरी इजी सम्स. जस्ट पुट द वैल्यू एंड गेट योर आंसर्स.